The compound linear type curve has been developed for horizontal multifrac wells and is available for gas, oil and water. In rate time, and pressure time variance. The pressure time type curve is a constant rate solution, and the rate time type curve is a reciprocal of this. The following flow regimes are represented on the type curve. Primary linear flow into fractures is denoted by the first straight line with a subsequent transition before compound linear flow is reached. The theory relating to this type curve, like all other type curves, can be found in our help pages. Analysis of this type curve is similar to the other type curves. After achieving your matchular data, you select a best matched type curve with each one corresponding to a different XS-XF ratio, where XS is the fracture spacing and XF is the fracture half length. Then, as the type curve was derived from a single fracture model, the number of fracs needs to be entered. Alternatively, you can enter here the length of your horizontal well instead. After doing this, now the permeability, fracture half length, and distance between fractures have been determined, along with XF square root K and XS square root K. In order to determine OGIP, EUR, GP, and remaining recoverables, a reservoir width or well spacing needs to be entered. By doing this, a boundary dominated flow diagnostic line is also displayed on the type curve, showing where boundary dominated flow would be expected to start. This type curve also has the ability to account for the presence of skin. Skin will be visible in the early time data and can be identified by the data not lining up on the chosen type curve. Right-clicking and dragging up and down allows you to drag the data to fit on the type curve, thus accounting for skin. And by doing so, the following values are calculated: the dimensionless pressure loss due to apparent skin, the apparent skin, the dimensionless apparent fracture conductivity, and the actual pressure loss due to apparent skin, which is determined from the last 5 flow rates. This type curve also differs in that it now contains the square root derivative form of the type curve. This is effectively a rotation of the raw data derivative, resulting in the linear flow regimes being horizontal lines. This may aid your matching your data, particularly when the data is messy. In conclusion, this type curve is great as a diagnostics tool for determining flow regimes, where you are in a particular flow regime, and also for seeding analytical models.